Okay, remember that the acronym CPCTC stands for corresponding parts of congruent triangles are congruent. So what we have here is we have a proof to complete, and our final reason is going to be corresponding parts of congruent triangles are congruent. That is our last step in the process. If we look at what we're given, it says that segment AB is perpendicular to segment BC. That means there's a right angle there. Segment DC is perpendicular to segment BC. That means there's a right angle there. We are also given that segment AC is congruent to segment BD. And I don't know how to mark that other than to just really color them the same color. So I'm going to do that. As you look at the picture, I want you to notice that we actually have two triangles going on here. We have this triangle that I just colored in, BDC, and we have this triangle that I'm trying to color in yellow, and you can see that they overlap at a certain point. So what we can say for BC is congruent to BC, that is our reflexive property that I told you was going to show up a lot in this module, and here it is. And then definition of perpendicular, if we look back at our definition, it says that right angles are formed. So that would tell us that angle ABC and angle DCB are right angles. There's a symbol for angles. So that perpendicular, we already marked it in our picture, but the name is DCB is one of them, and ABC is the other one. And then because we know that all right angles are congruent, we can then say that angle ABC is congruent to angle DCB because right angles are congruent. And so we're kind of lined up to use possibly hypotenuse leg here to say that the triangles are congruent because we just showed, we saw the hypotenuse are congruent to each other, and BC, which is a leg, is congruent to itself. And so we have the hypotenuse of a right triangle and the leg of a right triangle congruent in two different triangles. So that is our reason that those two triangles are congruent. And then we would be able to say, finally, our last statement would be to say that, yes, AB is congruent to DC because of corresponding parts of congruent triangles are congruent. Okay, so here's another one we're going to go for. So let me mark our given. It says that YW bisects XZ. So that means that W is a midpoint because it's on the bisector. And we are also told that segment XY is congruent to segment YZ. That's given. And then we know that segment XW is congruent to WZ by segment bisector definition. And I'm still writing it in orange because it's something that we got directly from the given. And then YW is congruent to itself because of the reflexive property. And, oh, I forgot to mark that these guys were congruent to each other, even though I said it in statement 2. Let me go back and rewrite that in light blue so you know what goes with. And so then we would say that these two triangles are congruent because of side-side-side postulate. And then we would say that the final reason that we could say that angle XYW, this angle, is congruent to ZYW is because corresponding parts of congruent triangles are congruent. Okay, another short little proof here. We have our given segment NO is parallel to segment MP, so I'm going to go mark the parallel stuff on the picture. We're told that angle N is congruent to angle P. So I'm going to mark that on the picture. And that's the rest, that's all our given. So then we have angle NOM, which is talking this angle, says it's congruent to angle PMO right here. And we know that's true because those are alternate interior angles. And we have the theorem that says if two lines are parallel and cut by a transversal, then alternate interior angles are congruent. And then we have that segment MO is congruent to segment MO, and that is reflexive property. And next, okay, that was strange. That only lasted for a second, but interrupted me. Anyways, so we have angle, side of this big triangle MNO is congruent to the angle, and the side of this triangle OPM. So that's angle, side theorem. And then because of angle, side, we know that angle NMO, which is this angle, and actually I'm going to mark it differently just so we can, and simply, is congruent to POM, and we know that by corresponding parts of congruent triangles are congruent. But then this is taking us to yet another step, and that step is to show that segment MN is parallel to segment OP. And if we go back to module 3, the second part, we know that that would have to be the case by alternate interior angles converse. Because remember, the converse in those cases told us lines were parallel. So we would know that those are parallel because the fact that NMO and POM, those angles are congruent. So now you have a sheet to complete in class, and you'll get it after you take your quiz over the material that we're quizzing on. So